Hello students, in this video we will solve specimen paper 4, it's Cambridge IGCSE, and a video from question number 1 to question number 6 from specimen paper 4 has been uploaded. In this video we will solve question from question number 7 to question number 12. So state a typical value for the speed of sound in air. At 0 degrees centigrade, you can write this answer that the speed of sound in air is about 331 meter per second. A sound wave in air has a wavelength of 22 millimeter. Using your value for the speed of sound in part A, calculate the frequency of the sound wave. We know that V is equal to F lambda, where F is frequency, V is speed and lambda is wavelength. So frequency is equal to speed divided by lambda. Now for V, we will write 331 meter per second, the speed of sound in air, divided by 0.22. It is 22 millimeter. So it will be 0.22 meter, and frequency is equal to approximate value is 1500 hertz. In this figure, this shows a solid block made from hot liquid metal. As the liquid cooled, a bubble formed inside the block. The bubble is not visible from outside the block. Describe and explain how to use ultrasound to determine the size and position of the bubble inside the metal block. You may draw on the diagram. So we can write that a transducer emits the sound waves that bounce off of various front and back of the bubbles and receives reflected pulse of ultrasound. Using the speed of the sound in metal and measure the time to took. Use the speed of sound in metal and measure the time it took to get reflected back from the front and back of the bubble. In this way, we can identify the position and size of the bubble by applying the relation as distance is equal to 1 by 2 multiplied by speed multiplied by time. So you have to divide it by 2 here, because the time you will get is a sound wave when it is reflected from the bubble, and you have to find the position of the bubble. So we will calculate the distance from the transducer to the bubble. So we have to divide it by 2 here. This figure is a circuit diagram. Calculate the combined resistance between Y and Z. So here we can see that 8 ohm and 4 ohm, two resistors are in series. So it is 12 ohm, and then the combination of 12 ohm and 6 ohm resistors are in parallel. So the resultant resistance will be 1 by Rp is equal to 1 by 12 plus 1 by 6. Then Rp, where P stands for parallel. So resultant will be 4 ohm. Calculate the potential difference across the 8 ohm resistor. So now we can see that the combination of 8 ohm and 4 ohm in series, and it is connected across YZ. So the potential difference across YZ is 24 volt. And since these two resistors are in series, so same current will pass through 8 ohm and 4 ohm. Let's say I1 current is passing through 8 ohm and 4 ohm. So we can calculate the value of I1. We know that current is equal to V by R. V is 24 and R, the total resistance is 8 ohm plus 4, it is 12. So we can calculate I1. I1 is 2 ampere. Now the potential difference across 8 ohm resistor. Please write here ohm unit, 8 ohm resistor. It will be current multiplied by resistance. Resistance we have 8 and current we have calculated, it is 2 ampere. So the answer is 16 volt. This figure shows a conducting ball that oscillates between two charged plates. These are the two charged plates. As the ball oscillates, it touches each plate in turn. Referring to the charge on the ball, explain why the ball moves to the positive plate after touching the negative plate. So this is a positive plate, negative plate, and they want us to explain why the ball moves to the positive plate after touching the negative plate. So after touching the negative plate, the negative charge gets deposited on the ball. So the ball becomes negatively charged and moves toward the positive plate. State which particles move when there is a current and state the direction in which they move through the sensitive emitter. So the particles which is involved in the conduction of current is the electron, and direction will be from left to right through the emitter. As the electron has a negative charge, so it is attracted toward the positive plate, so the direction will be from left to right. For each complete oscillation of the ball moving between the plates, a charge of 8.5 into 10 to the power minus 10 coulomb is transferred from one plate to the other. The frequency of oscillations is 4 Hz. Calculate the current shown on the sensitive ammeter. Calculate the current shown on the sensitive ammeter. We know that Q charge is equal to IT, where I is for current and T stands for time. And we know that frequency is 1 by T. So I current is equal to Q and divided by T, or 1 by T is equal to frequency. So the current I will be equal to charge Q multiplied by frequency. Put all the value you have. For Q you have 8.5 into 10 to the power minus 10. For frequency you have 4. Calculate I, it is 3.4 into 10 to the power minus 9 ampere. An americium nucleus decays by the emission of an alpha particle into a neptunium nucleus. Complete the nuclear equation for this decay. So we have written the nuclear equation here, and we know that for alpha particle the symbol is 2 alpha 4, where 2 represents the atomic number of proton, and 4 is the total mass number of nucleon. So you can note down. Americium is used to smoke detectors. Explain why beta emitters or gamma emitters are not used in smoke detectors. So when the smoke enters a smoke detector, it is bombarded with particles and it is ionized. The ions are then detected. Since gamma and beta emitters will not produce enough ions pairs per centimeter, so these are not used in smoke detectors. The half-life of this americium nuclide is 470 years. A sample of this nuclide contains 8 into 10 to the power 14 atoms. After some time, 6 into 10 to the power 14 americium atoms have decayed. Calculate the time required for this decay. The meaning of half-life is the time required for half of something to undergo a process. So number of atoms remaining, 8 into 10 to the power 14 atoms minus 6 into 10 to the power 14. This is 2 into 10 to the power 14. So 4 into 10 to the power 14 atoms remain after 470 years, because the half-life of americium nuclide is 470 years. Means the half of atoms, 4 into 10 to the power 14 atoms, would remain after 470 years, and then again half of 4 into 10 to the power 14 atoms means 2 into 10 to the power 14 atoms would remain after another half year. 470 plus 470, 940 years. So this is the answer. Describe and explain how a stable star is formed. The star begins as a nebula. This is simply a cloud of gas, rock, and dust. When this cloud is drawn together by gravity, it is called a protostar. Gravity is the attractive force that causes these fusion reactions. As the protostar forms, its core will undergo fusion reactions. And due to this fusion energy, another force acts on the star that pushes the matter of a star outward. In a star, outward force due to fusion energy balances the inward force of gravity. When these forces are equal, the star is in equilibrium. Describe and explain what can be deduced from cosmic microwave background radiation, CMBR. The cosmic microwave background radiation is a faint glow of light that fills the universe falling on Earth from every direction with nearly uniform intensity. Radiation was produced when the universe was formed. So this radiation is invisible using optical telescope. Radio telescopes are able to detect the faint signal. These signals are strongest in the microwave region of the radio spectrum. So this is evidence that the universe expanded. This figure shows a transformer. There are 8,000 turns in the primary coil of the transformer. The primary coil is connected to a 240 volt main supply. A 6-volt lamp connected to the secondary coil operates at full brightness. Calculate the number of turns in the secondary coil. So number of turns, we know this relation where S stands for secondary coil, P for primary. So Ns upon Np is equal to Vs upon Vp. So Ns is equal to, rearrange this relation, Np multiplied by Vs divided by Vp. Np, number of turns in the primary coils, 8,000. Vs, voltage across the secondary coil, it is 6 volt divided by Vp. Vp is the voltage across the primary coil, it is 240 volts. So put all the values in the relationship and number of turns in secondary coils are 200. The current in the lamp is 2 ampere. The transformer operates with 100% efficiency. Calculate the current in the primary circuit. So use this relationship IP Vp is equal to Is Vs. We have all the values, we have everything, and IP is equal to 0.050 ampere. Thank you for watching this video, and I hope you like this video. Please like, share and subscribe, and don't forget to leave your comment here. Thank you very much once again.